in mind the signs will alternate. It will result in that. We don't have to memorize that, but it's easier if you do. Now, you can determine the coefficients because there is not going to be any multiplications here, right? Because this is 1 and this is 1. In the previous example, we had 2 and we had x squared. It was more complicated. But here, the coefficients will only be the raw coefficients. We can determine them. So this is for 3. Oh, this is for 4, and this is for 5. So I can determine them using Pascal's triangle, or I can find 5 choose 0, which I know what it is, 5 choose 1, 5 choose 2, 5 choose 3, 5 choose 4, and 5 choose 5. Or I already have them from here, from Pascal's triangle. So I have 1, x to the 5th, but now it's minus 4, x to the 4th. And there is nothing because it's 1. I don't even need to calculate with this.
Yeah, I'm kind of confused. Like, why don't you use the 1 or like the second? Like you said in the example we did, you have to go until like it cancels out. And I just don't, I don't know, I'm just confused about the whole process.
So on this problem, so let's finish this one and we can look at another. So,
Okay, so how did you get x to the 5? Like, I just see it's x to the 5, but then why wouldn't you do, I guess it's just 5 to the 1. So that would just be 1. I don't know. I'm just confused at how you're getting these numbers.
you mean because there are no numbers other than 1 here?
Can you just explain how you're, like, when you're writing x to the 5 minus 4x to the 1, where you're getting those from?
Yes. So a plus b to the nth power.
Yeah.
N choose 0, a to
Yes.
the nth, plus n choose 1, a to the n minus 1 times b, plus n choose 2, a to n minus 2 times b squared, plus n choose 3, a to n minus 3 times b to the third, plus n choose 4, a to n minus 4 times b to the fourth, plus dot, dot, dot. Since I already have the coefficients determined with Pascal's triangle, this is 1 times x to the 5th. Because it's minus, I have to alternate the signs. And choose 1. I already have it, it's 4. And the power of the first term has to decrease from 5 to 4. There is nothing else, so I don't have a b, so that's why b is gone, because it's 1.
Mm-hmm.
Plus, the next coefficient is 6. From 5 to 4 to 3. Minus 4. From 5 to 4 to 3 to 2. And plus 1. 2, 3, 4. It's 5. Sorry. 1, 5, 10, 10, 5, 1. So 1. I have to start all over because for some reason the power is 5, so I have to move on to. I have to have 6 terms. I cannot have just 5. Okay. So I have x minus 1 to the 5th, x to the 5th minus. The next coefficient is 5. 5, x to the 4th, plus 10, x to the 3rd, minus 10, x squared, plus 5, x, and minus 1. So the coefficients were determined with Pascal's triangle. 1, 5, 10, 10, 5, 1. The power of x starts from 5 to 4 to 3 to 2 to 1 to nothing. Power of 1 from nothing to 1 to 2 to 3 to 4 to 5, but there is nothing I can show because it's just 1. When we look at the other example, or you can make one up, it doesn't have to be this, but if you want 2x plus 3 to the 5th power, for example, this is what we have. Coefficient 1, 2x to the 5th power, minus, it's plus 5, 2x to the 4th power. It decreased by 1, but then 3 pops up to power 1. And then plus coefficient 10. 2x went from 5 to 4, now to 3. 3 went from 0 to 1, and now to 2. Plus the other 10. Power 5, power 4, power 3, so now it's power 2. For 3, power 0, power 1, power 2, so now it's power 3. Plus 5. First term, power 5, 4, 3, 2, just 1. The next one, which is 3, power 0, power 1, power 2, power 3, power 4. And the last one, 2x is gone, the coefficient is 1, I only have 3 to the 5th power.
So it's like the first, when you have the 2x plus 3, the 2x, the exponents are going to count down to 0, and then it's kind of like the opposite for
Exactly.
the second number. And that's
Exactly.
determined by the.
So from n minus 1, n minus 2, n minus 3, n minus 4, and so on and so forth. No b, b to the first, b to the second, b to the third, b to the fourth, and so on and so forth, till you exhaust.
And how do you know when to stop when
You know
you just
when to
match the
stop.
next third?
You know when to stop based on the power.
Okay.
So if the power is 5, you have to have 6 terms. 1, 2, 3, 4, 5, 6. If the
Yeah.
power is 10, I have to have 11 terms. If the power is 2, as we know, and I've been asking that for 3 months, right? 3 terms.
Okay. Yeah, I'm starting to understand it now. I need to do more, but I was just confused. I didn't see that pattern, I guess, at first.
Is it better now?
It is, yeah.
It's not finished though,
Okay,
because
you
I have to
like,
determine all these coefficients. 2 to
Yeah.
the 5th is 32, x to the 5th, plus 2 to the 4th is 16 times 15. 5 times 3 times 2 to the 4th power, which is 16. So I got 240 x to the 4th plus 10 times 9 is 90, multiplied by 2 to the 3rd, which is 8. I don't need that. It's 720 x to the 3rd plus, I'm here, 27 times 10, 270 times 2 squared, which is 4. So plus 1080 x squared. So power 5, power 4, power 3, power 2. We're here now. 3 to the 4th, 81 multiplied by 10, yeah. So 810 x plus how much is that? 243. 1, 2, 3, 4, 5, 6 terms.
Okay.
Is it
Thank
better?
you for, it is. Thank you for staying on.
Oh, yes, of course. So the idea is we start with 2x to the 5th power, and it
Yeah.
decreases till it disappears.
Mhm.
And we start with 3 to 0 power, which means 1, and it decreases till it takes over till 3 to the 5th. So what
Yeah,
happens
so-
to 2 to the x has to happen to 3.
Okay. Yeah, thank you.
Is this better?
Yes.
Perfect. I'm going to post this too. So always remember, you have to have one more term than the power. Always. That's why we said a binomial squared is 3 terms. A binomial to the 10th is 11 terms. A binomial to the 5th is 6 terms. Always one more than the power.
Yeah, you think it would be beneficial to write out that triangle or like print something out that has that?
Yes, or you can determine the
Okay.
coefficients. What coefficients? These ones in front.
Mhm.
These can be determined with 5 choose 0, 5 choose 1, 5 choose 2, 5 choose 3, 5 choose 4, 5 choose 5.
Okay.
For huge numbers, if it's a power 15, I'm not going to do this. It's
Yeah.
going to take me 3 pages. I'm going to use 15 choose 0, 15 choose 5, and so on and so forth. But if it's just power 5, it's more convenient to use Pascal's triangle.
All right.
But beyond 10, it's way too
Yeah,
much.
it would be too much.
Yes, I will need a whole page to create Pascal's triangle.
Okay. Well, thank you. once
My
again.
pleasure, of course. Feeling better?
Yeah.
Excellent. I'm going to post all this together
that's
with it.
fine.
Yes. Thank you. Thank
Okay.
you for
Have a good night.
Have a good night.